All right, so let's get going on today's meeting. Now, last time we met, we introduced the idea of the ANOVA and specifically took a look at why we need an ANOVA when we're doing multiple tests. And today we're going to dive a little bit more into what an ANOVA exactly is and also hand over the calculations of the ANOVA to the robots, to SPSS, the statistical package that can be used for doing these types of calculations. So we're going to take a look at how to do a one-way ANOVA in SPSS, how to set up your data, how to run it, and then how to interpret the output correctly. And all of this is in service of our goal of being able to do inferential statistics, to be able to take a look at samples that we can measure, samples that we can find out everything about, and then infer that to populations that we can't measure, populations that we can't figure everything out. And again, what that allows us to do, it allows us to take psychology from being able to help just a select few, that is the sample, and transforming it into a practice that can help the entire population, which is where we can make the most impact. So we're going to continue on with this look at inferential statistics. And then also today, it is an SPSS day, so we are going to have a Do It With Me demo where we take a look at a real psychology study that answered the question of whether it not necessarily is better to give than to receive, but when is it better to give? Does it matter the conditions that you give under? We're going to take a look at all that and more today. So the plan for today, we're going to start off our look. We're going to do our deep dive into one-way ANOVAs. We're actually going to start off with a look at the different types of ANOVAs. So the same way we had different types of t-tests, we have different types of ANOVAs, and you need to know which situation calls for which type of ANOVA. Then we're going to take a look at the one-way ANOVA, which is one of those particular situations. We're going to talk a little bit about variance, which is the foundation upon which ANOVAs are built. ANOVA literally stands for analysis of variance. So we'll talk about the variance that is getting analyzed, specifically the total variance and the between groups variance, and then also the within groups variance. So we'll talk about what each of those is in time. And then we'll take a look at SPSS, and we'll have a Do It With Me demo that you can follow along with. And we're going to take a look at a study by Aknin et al., Making a Difference Matters, Impact Unlocks the Emotional Benefits of Prosocial Spending, that basically took a look at what circumstances determine whether giving somebody something, whether giving somebody a gift actually makes you feel better. So we'll take a look at that study. And we chose it because, number one, it is interesting just to know what the effect of a gift is upon the giver. But also, it is going to be analyzed using a one-way ANOVA. So a perfect example of what we want to cover today. So let's take a moment to think back to when we were looking at t-test. And if you recall, we introduced the t-test and mentioned that there were three types of t-tests. There was the one sample t-test, where you have one sample that you analyze against a known or hypothesized population mean. There was the two sample t-test, where you had two samples made up of two different groups of individuals. Each one was treated with one condition, and then you compared those two groups to each other. And then we had the paired t-test, and the paired t-test was where you only had one sample, but you measured them before, and then you measured them, for example, after a treatment. So it's one sample measured under two conditions, and then you compare that sample to itself under each of those two conditions. So those were great times, three different t-tests, and we had all the t-tests covered. Now we're going to introduce the idea of the different types of ANOVAs. And as we're going to see, I'm going to call this the 5-ish types of ANOVA tests, because there are literally millions of different combinations of this that you can have. So we'll just talk about the 5-ish general categories of ANOVA tests. So let's begin by comparing the most simplest ANOVA tests to their t-test counterparts. So for the two sample t-test, in the two sample t-test, you had one sample that would be given one treatment, and then you had a different sample of individuals that would be given another treatment. So your classic study here would be that one sample gets drug A and one sample gets drug B. and then you compare the effectiveness of the drugs by comparing the responses of the two samples. Well, that's great if you want to ask about drug A versus drug B. But what if you have more than two drugs? What if you want to ask, is there a difference between drug A versus drug B versus drug C versus a placebo? Now you have 4 different conditions, 4 different sets of subjects in 4 different conditions. And for this, you would run a one-way ANOVA. Now, one-way ANOVA is the short form of referring to an independent samples one-way ANOVA. The independent samples is assumed when you say one-way ANOVA. So we're going to be consistent with that. We're going to call it a one-way ANOVA. But remember, it is a one-way independent samples ANOVA where each condition has a different set of subjects in that particular condition. So that is the first-ish category, is the one-way ANOVA. And then the next category, we'll compare it to its underlying t-test cousin. So if you remember the paired t-test, we have one group of subjects and they're tested before and after, for example, administering a drug. So you might think to yourself, well, I'm going to test if drug A is effective. So I'm going to measure the levels in a sample before being administered the drug, and then I'm going to measure their response after being administered a drug. But what if you want to measure the response before being administered the drug, immediately after being administered the drug, and then at a 1-month follow-up, and then at a 6-month follow-up? So you're tracking the same individuals, but you're tracking them before, and then immediately after, and then at a 1-month follow-up, and then at a 6-month follow-up. Now you have 4 conditions that you want to test, no longer being able to do a paired t-test. Now you are doing a one-way repeated measures ANOVA. So the one-way in the ANOVA, that refers to the fact that there is only one independent variable. So in this case, we have the independent variable of time. Was it before the drug, right after the drug, a month after the drug, or 6 months after the drug? So there's only one variable. At what time are we measuring the response to the drug? So that is where the one in a one-way repeated measures ANOVA occurs. All right, so we have now 2-ish categories of ANOVA. Let's go back to the one-way ANOVA. Remember, this is the one-way independent samples or independent means ANOVA. And let's say that instead of just wanting to test drug A versus drug B versus drug C versus a placebo, which we could do with a one-way ANOVA, let's say that we also wanted to know, do these drugs interact with a person's diet? So for example, are the effects of the drugs different for vegetarians compared to omnivores? Now we have 2 independent variables. We have the drug A, drug B, drug C, or a placebo. That's variable number 1. And then we have the diet of the individual, vegetarian or omnivore. That's variable number 2. In this case, we need to basically double that ANOVA, and we get what is known as a 2-way ANOVA. So again, for the independent means or independent samples ANOVAs, that independent samples is implied. So for the 2-way ANOVA, we understand that means the independent samples or independent means ANOVA when we omit the description of exactly what kind of ANOVA it is. So when we say 2-way ANOVA, it means a 2-way independent samples ANOVA. 2 different independent variables, 2-way ANOVA. And now let's revisit our one-way repeated measures ANOVA, where we are testing drug A before being administered, immediately after being administered, 1-month follow-up, and a 6-month follow-up on the same individuals. And let's say that we also had drug B, and we wanted to test the effects of drug B on those exact same individuals. So we give them drug B as well, and we test them before, and we test them immediately after administering drug B, and then at a 1-month follow-up, and then at a 6-month follow-up. And let's assume that we counterbalance everything, so there's no order effects or anything about taking drug A versus drug B first or vice versa. Let's say that everything is taken care of just for argument's sake here, but we have 2 different drugs. That's our first independent variable, drug A versus drug B. We have 4 different times. We have before the drug, after the drug, 1-month follow-up, 6-month follow-up. We have the same people taking both drugs, So now instead of a one-way repeated measures of ANOVA, we double that and we have ourselves a two-way repeated measures ANOVA. So two-way for the two different variables, drug type, drug A or drug B, and time it was administered, before, after 1 month follow-up, or the 6-month follow-up. And then the last category-ish of ANOVAs that we're going to introduce today, let's say that you were doing this study and you thought to yourself, you know what, it's impossible to test the effects of drug A and drug B if we're giving them to the same sample, right? If we're giving them to the same people, drug A might interfere with drug B, and that's going to kind of muddy the waters, and we really don't want to do that. So why don't we set it up where we have different samples taking each drug. So one sample will take drug A, and then one sample will take drug B. A different group of people will take drug B, but we still want to measure them before the drug, immediately after the drug, 1 month follow-up, and a 6-month follow-up. Well, now we basically combine the idea of a independent samples design, because there's one sample that is being given drug A, and there's one sample that is being given drug B. So the drugs are an independent samples design, but then we measure those two groups 4 different times, before, after 1 month follow-up, and 6-month follow-up. So the time that we test them at after the drug was administered, that is a within subjects design. So now we've combined an independent means design with a paired samples design, and we have ourselves a mixed design ANOVA. And with these types of ANOVAs, you can go 2-way, you can go 3-way, you can go 4-way, basically as many independent variables as you want. Theoretically, you can do that. In my own experience, I kind of find once you go beyond 3 independent variables, it gets really hard to make sense of the story. But that's just an aside. You could go beyond it and do a 5-way, 6-way ANOVA. And then you can have all of the samples being independent, in which case you have an independent means ANOVA, or you can have one sample that experiences every single condition, in which case you have a repeated measures ANOVA, or you can split it up where some variables have different samples receiving each condition, other variables have the same samples receiving each condition, and you have yourself a mixed design ANOVA. And basically you can stack variables and conditions as much as you want. The ANOVAs can take it. They are a very versatile group of class of statistical tests. So ANOVAs, as you can kind of visualize, can get very, very complicated. So complicated is not what we want to do for an introduction to statistics course. So we are going to start with the simplest of the ANOVAs, and we're going to focus on the one-way ANOVA. So again, get into the habit. When you hear the word one-way ANOVA, without any other qualifiers, that means a one-way independent means ANOVA. That means that every single condition in this ANOVA, there's only one variable, and every single condition gets a different set of subjects. So the subjects are independent of each other, and that's what we refer to when we refer to a one-way ANOVA. All right, so what are we going to do to analyze this one-way ANOVA, or to introduce this one-way ANOVA? What we're going to do is we're going to take a look at a very interesting study by Aknin et al. Called Making a Difference Matters, Impact Unlocks the Emotional Benefits of Prosocial Spending. So we're going to take a look at a very clean experiment that asks a very simple question: when does spending money on others actually make us happier? So in this study, we're going to focus on study 2, where the researchers recruited 181 adults online, and everyone got the same instructions and everyone did the same task, but what changed was what they were asked to remember. And basically this matters because the entire point of the study was to isolate the emotional impact of recalling a spending experience depending upon the type of experience that you were recalling. So what were the 3 types of experiences that the subjects that were recruited were being asked to recall? Well, each subject was asked to recall only one experience, and they were randomly assigned to the 3 conditions. So what were those 3 conditions? Well, to kind of set the stage first, they would ask when you were, for you to recall a time previously in your life when you spent around $20 to give somebody a gift. right? So when in your previous life, recall a time in your previous life when you spent money on somebody else. So there were three conditions to this question. Condition number one is called prosocial boost. And in this case, the subjects that were in this condition, they were asked to recall a time that you spent money on someone else. So you bought somebody a gift and you gave them a gift. You spent money on someone else, and the spending had a meaningful positive impact on that person. So the prosocial is that you're spending it on somebody else. The boost is that it had a meaningful impact on that condition. So you can think of this as the helping that really mattered condition known as the prosocial boost. So again, think of a time when you spent approximately $20 on someone else and that had a meaningful impact on that particular person. That was condition number one. The next condition was the prosocial blocked condition. And in the prosocial blocked condition, the subjects that were randomly placed into this condition were asked to recall a time that you spent money on someone else, but the spending did not have a meaningful impact. So your gift fell flat. This would be, you can think of this as the I tried to help, but it didn't change anything condition. So in the prosocial blocked, still you're thinking about that time that you spent approximately $20 on someone else, but this time it did not have a meaningful impact. So it's prosocial, you are helping somebody else, you are giving somebody else a gift, but in this case, it's blocked. It did not have a meaningful impact. And then the final condition removes the entire prosocial aspect of this, and it is the personal spending condition. So in this condition, the subjects that were randomly assigned to this condition were asked to recall a time that you spent money on yourself. And this would be the neutral baseline. There's nothing prosocial, there is no impact. And they were just asked to remember, hey, remember a time when you spent approximately $20 and that was for yourself. So note that in this study, the three recollection tasks, they're very similar. Same dollar amount, same vivid recall, but they differ in the perceived impact, which is what we're trying to take a look at. What is the effect of that perceived impact? So does it make a difference whether you spent money on yourself, the personal condition, or you spent money on somebody else and it really helped, the prosocial boost condition, or you spent money on somebody else and it didn't really help, the prosocial blocked condition? Do those change the psychological effect of the giving? So how did they measure the psychological effect of the giving? Well, what they wanted to measure was they wanted to measure basically happiness. They wanted to say, hey, after you recall this episode, how did that make you feel? How did that particular act, that particular behavior, recalling that behavior of prosocial giving, how did that make you feel? So for that, they used two different measures. So I'll read this directly from the study. So participants then reported, so this would be after vividly recalling that memory, they reported their subjective well-being, so SWB, subjective well-being, on a cognitive and affective measure. Current positive affect was reported on the positive and negative affect schedule, which included the word happy. So this is the PNAS, and this is basically where you rate how you're feeling on a scale from 1 very slightly or not at all to 5 extremely. So it might have a question such as, at this particular moment, how are you feeling? Are you feeling happy? 1, very slightly or not at all. 5, extremely happy. There's a number of different items, and then that gives you a global score of positive, how you're positively feeling in the moment. And then they also had overall cognitive evaluation of life on the satisfaction with life scale, the SWLS. And again, this is a scale where you rate different items. 1, strongly disagree, to 7, strongly agree. And this is basically your overall cognitive evaluation of life. Now, what they actually found was that both of those scores in this study were highly correlated with each other. So if you scored high on the PNAS, you scored high on the satisfaction with life scale. If you scored low on the PNAS, you scored low on the satisfaction with life scale. So what they did is they combined those two scales into a single subjective well-being score, and that gave them one measure on the subjective well-being of these subjects after they recalled the event. So basically, to kind of sum up the study here and the study design, We have one condition, the prosocial boost, where subjects were asked to recall a time when they spent $20 on somebody else and it had a positive, meaningful impact on that other person. And then we have condition number 2, which is the prosocial blocked. And this is when you recall, these are completely different subjects, recalled a time when they gave somebody a gift, approximately $20, and it had no meaningful impact on that other person. And then finally, the third condition, the personal condition, was when you spent $20 on yourself. And then after a subject recalled one of those experiences, and I keep harping on that just to make sure that you understand, no subject recalled all 3 experiences. They were either asked to recall a prosocial boost experience, a prosocial blocked experience, or a personal experience. After they recalled their particular experience, they completed those measures of subjective well-being. And the question is were the givers in this group, did they feel better? Was their subjective well-being score higher than the individuals in this group? Or I should say different than the individuals in the prosocial blocked group? And were the individuals that gave a gift away, was their subjective well-being different than the individuals that bought something for themselves? So those are the 3 conditions. And again, the dependent measure was how did the subject who recalled that episode feel about themselves, about their subjective well-being. So let's take a look at the null hypothesis and the research hypothesis now. So we'll go back to the prosocial boost because that's the most uplifting picture that we have here. So the null hypothesis, again, stated in terms of population means. So we're going to state this in terms of the population subjective well-being. And the null hypothesis is that the average well-being in the population of prosocial boost individuals equals the population mean well-being in the prosocial blocked population equals the average subjective well-being scores in the personal giving population. So we have 3 different populations of people that gave to other individuals and it was a meaningful experience, population of individuals that gave to others and it was not a meaningful experience to the other person, and then a population of individuals that kept things for themselves. And the null hypothesis is that there is no difference in average subjective well-being scores across those 3 populations. Now, the alternative hypothesis, the research hypothesis, is that at least one of those population means is different. So we have 3 population means here. Null hypothesis is that they're all the same. They're all equal. Research hypothesis or alternative hypothesis is that at least one of those population means is different. And again, we saw this in the previous meeting when we were talking about multiple t-tests. We write it out as a single sentence because if we were to write this out in terms of a mathematical formulation like we do with the null hypothesis, it would get massively complicated. So you would need something like this. You would need to have an alternative hypothesis that said, well, my alternative hypothesis or research hypothesis is that the mean for the prosocial boost population does not equal the mean for the prosocial blocked population, does not equal the mean for the prosocial personal population. But notice that this is only one condition where all the means are different. It's quite possible that we have another version of the alternative hypothesis where the prosocial boost population does not equal the prosocial block population. The prosocial boost population does not equal the personal population, but the prosocial block population does equal the personal population. So in this case, there's still a difference. Basically, prosocial boost is different from the other 2 types of giving, and the other 2 types of giving do not differ from themselves. So that's another possibility. We have a third possibility here, that the prosocial boost population does not equal the prosocial block population, but the prosocial boost population does equal the personal population. Prosocial block population also equals the personal population. So prosocial boost does not equal prosocial blocked. So meaningfulness is important in terms of social well-being. But prosocial boost might equal personal because giving to somebody and it's meaningful might feel good. Giving to yourself might also feel good. And those subjective well-beings might be equal. So here's another situation that is possible And in reality, I can't even fit all the different possibilities here because there's just so many different permutations. So rather than writing out all of these different possibilities in these mathematical formulas, we're going to take advantage of our human minds and the way our human minds can understand English. And we're going to say, hey, instead of writing all this, alternative hypothesis, research hypothesis, at least one mean is different. And this one sentence covers all of these situations here. So that is the alternative hypothesis, the research hypothesis. That is what we are going to go with. All right, so now we've set up the study, we've set up the experiment. Now it's time to go to SPSS. So if you haven't already, I would highly recommend, if you want to follow along in your browser, open up SPSS if you have access to that. Open up the Statlet for the F distribution. We're going to be using that to visualize what it is that we're actually testing. And then open up the one-way ANOVA SPSS demo Excel sheet. So the Statlet and the one-way ANOVA, if you're watching this on video, those links are available in the description. So highly recommend that you open those up right now, pause the video so that you can follow along with the Do It With Me demo that we are about to undertake and really kind of lock in that procedural learning of actually going through and doing the SPSS with me. All right, so here's your last chance to pause the video. All right, and we are off to the races. So what we're going to do right now is we are going to go to our one-way ANOVA SPSS demo Excel sheet, and we're going to start off with this sheet here where we have the raw data. So it should look like this. We have subjective well-being here. We have the condition that the subjects were in. We have prosocial boost. We have prosocial blocked. And then we have personal down here. We have 60 subjects in the prosocial boost, 60 subjects in the prosocial blocked, and then 61 subjects in the personal condition. This is hypothetical data that is designed to mimic what it was that Aknin et al. Found, just to be completely clear. And then over here for the subjective well-being scores, we have the mean and standard deviation for the prosocial boost sample. We have the mean and standard deviation for the prosocial blocked sample, and we have the mean and standard deviation for the personal sample here. So those are just our way of ensuring that we know the data that we're working with and our way of being able to double check that with SPSS, which if you've been following and watching my previous videos, you know that double checking SPSS is crucial. So always use Excel to maybe calculate those values out so that we know what it is that we need to double check against in SPSS. But importantly, in this case, we have our data formatted correctly because each one of these rows here is a different individual. So here we have an individual in the prosocial boost condition that had a subjective well-being score of 0.3. Here we had another person in the prosocial boost condition that had a negative subjective well-being score, so did not feel at all better for giving a gift that proved meaningful to somebody else. Here we have somebody that scored a 1.1 on subjective well-being, but importantly, every single person in every single condition gets their own row. And that is the most important thing when you are formatting your data for SPSS. Everybody needs to get their own row. So this person in the prosocial blocked sample, they get their own row. This person in the personal blocked sample, they get their own row. All 181 individuals get their own rows. So what we're going to do now is we're going to take this data and we're going to copy it into SPSS. And I'm just going to give you a foreshadowing or forewarning here. We're going to do it wrong the first time just to kind of solidify what can go wrong in SPSS. And then I'm going to show you the right way to do it. So don't be alarmed. Things are going to go south before things get done correctly. But let's start it up. So we have our IBM SPSS program open here. It's ready to go. It's in data view down here. So we are going to take our data and we are going to copy all of it. So we select it all using the Control Shift and arrow keys. So we have all the data collected. Control C to copy. We go over here to SPSS, click on column 1, row 1, Control V, and it'll paste that into SPSS. And you can see here that we have var 00001 and var 00002, horrible names for variables. So we're going to go down here to variable view, and we are going to change variable 1 to condition, because that is what is identifying which condition each subject is in. And then we are going to change variable 2 to SWB for subjective well-being. And if you are somebody that is doing research in this area, SWB, I usually don't like to use acronyms too much, but if you're in this area, SWB is going to be very intelligible for you as a human being with your human mind. So I don't mind using it right here. And it's also what the study uses. So now we have condition. Which condition were they in? We have subjective well-being. You can see I paused a little bit because this is not my domain, but we have subjective well-being. What was their subjective well-being score? So now it's time to do the ANOVA. So we're going to go here to analyze, and we are going back to compare means and populations. So it's been a while since we've been to this tab here, but we go to analyze, we go to compare means and populations, and very friendly, SPSS says, hey, we got this option here called one-way ANOVA. You want to do a one-way ANOVA? And we say to ourselves, heck yeah, I want to do a one-way ANOVA. So we're going to click on that. So again, we go to analyze, compare means and proportions, one-way ANOVA, and we click on that. And we see here that one of our variables is missing. So we have the subjective well-being variable. That one's here, that one's available. But where's our condition? Our condition variable is gone. How are we going to tell SPSS which condition these scores belong to? And that is what I wanted to show you here, because when you set up a t-test this way, it works perfectly. When you set up an ANOVA this way in SPSS, things break down. So we're going to have to set up our data slightly different. So we're going to close out of this, and we're going to go back to our Excel sheet here. And I knew this was going to happen. So instead of going to the raw data sheet here, we're going to go to raw data with nums. And nums are always good because num stands for numbers. And what we need to do our ANOVA in SPSS is we need to assign each condition, and I'm calling this the condit big N for numbers. We need to assign each condition a number. So we're going to assign prosocial boost the number 1. And then we're going to assign prosocial blocked, gets assigned number 2. It's the second condition. And then we're going to assign personal as the third condition. So we are going to now take all of these and we're going to copy all 3. So use the arrow keys, use Control Shift, down arrow key to highlight all of those, Control C to copy. And now we're going to go back to SPSS. We're going to go back to column 1, row 1. We're just pasting over almost exactly the same data. We're just adding a third column here. So we hit Control V, we paste it in, and now we have ourselves our numbers that indicate what condition each subject is in. Are they in condition 1, prosocial boost, condition 2, prosocial blocked, condition 3, personal. So once again, SPSS names variables the way it likes it named because it is a robot. But we can't deal with var 00003, especially when you start doing ANOVAs. There are going to be so many comparisons. This is your spoiler warning. There's going to be so many comparisons being made that if you keep these variables as var 0001, var 0002, you are going to lose it when you have to do your interpretation, when you have to interpret the output. So give yourself a big favor, spend that couple of minutes going down to variable view and saying, you know what, I'm going to call this condit with the big N, and we're doing this to keep it 8 characters or lower so that it always works across all of SPSS. And we go back to data view, and now we can see here we have our condition, prosocial boost, prosocial blocked, and personal. We have our subjective well-being scores, and now we have which condition they are in numerical values. Are they in condition 1, 2, or 3? So we're almost ready to do the analysis now. But what we're going to do is we're going to be even friendlier to our human minds, and we're going to change the way that the conditions are displayed in the output. And because we don't want SPSS to tell us the means of condition 1 in the output, and what the means of condition 2 are in the output, and what the means, for example, of condition 3 are in the output. We want it to tell us what are the means for the personal condition, and what are the means for the prosocial blocked condition, and what are the means for the prosocial boost condition. And again, you might think to yourself, well, I'll remember that 1 is prosocial boost, 2 is prosocial blocked, 3 is personal. You will in the moment, but you come back to this in 24 hours, in a week. You take a break and come back to trying to understand your experiment, and you will lose hours of time trying to recall which condition was which condition. And it also increases the amount of mental gymnastics you need to do when you are reading your output. And reading and interpreting output is challenging enough without adding extra difficulty to your own, to yourself. So we're going to do one last thing here. We're going to go down to variable view, and we're going to go to the condition row here, and we're going to go across here to values where it says none. And we're going to click on values, and we're going to click on this little button here with the 3 dots. And that is basically going to allow us to put value labels on each of our values. So what we're going to do here is we're going to add a value label. So we click on the plus, and the value that we're going to label is going to be the value 1. So that is condition number 1. And the label here, we're going to put personal boost, because condition number 1 was the personal boost condition. So we have personal boost in there, and then you don't have to worry about the spelling because it's not like it's going to be matched up with the other column. It's just for our own purposes, for our own interpretation. So we're going to add another one because we have 3 groups. So we're going to add the value 2, and then we're going to click over here for the label, and that is going to be personal blocked. And then you probably guessed it, we're going to add value 3, and that is just going to be personal. And then you can tell how much you might make mistakes here, because I put personal here. That should be prosocial. And I put personal here. That should be prosocial. And I apparently know what I'm doing with ANOVAs. So imagine how much more difficult this would be if you were struggling with this because you're doing this for the first time, and it's challenging. So once again, the more you can offload from your working memory into SPSS, the better it will be. So now we have value 1, prosocial boost, value 2, prosocial blocked, value 3 is labeled as personal. Those are all good. We hit OK. And now we go back to data view, and now we're ready to analyze our data. Now we're ready to run that ANOVA. So we go back to analyze, we go back to compare means, we go back to one-way ANOVA. Again, just going to point it out, SPSS, very friendly for this particular test. We click on that, and now look, we have our subjective well-being data, and we have our condition. So now we have to decide which one goes into the dependent list and which one goes into the factor list. The dependent list, that is your dependent measure. That is the dependent variable, what we were measuring in this experiment. Your factor here, that's your independent variable, what we manipulated. And what we manipulated was the condition. Did we ask them the prosocial boost question? Or did we ask them to recall the prosocial blocked encounter? Or did we ask them to recall the personal experience? So the factor in this case is going to be condition. So we highlight condition, and we use this arrow to move it into factor. If we ever make a mistake, we can just pop it right back out using the arrows. So we move that one into factor, and then the subjective well-being, our dependent variable, our dependent measure, that goes into the dependent list. And then estimate effect size for overall tests, that is by default checked. So we're going to keep that one there because it is a good thing to estimate your effect sizes. But over here, we're going to keep this pretty minimal here. So just to kind of show you some of the options that it has. For contrast, you will learn more about contrast in a more advanced statistics course. So we are going to ignore contrast for right now. And then in terms of post hoc, we're going to leave this out right now, but we are going to return to the post hoc option here in the next video. And then in terms of options, it has, again, all of these different options that you can choose. We are going to choose descriptive, and that is so SPSS will generate a descriptive statistics for this particular data set. So we want descriptive. Horrible idea to just click on everything, because you will end up with a 14-page ANOVA output where you have to search for the proper information. So always make sure when you're using a statistical program like SPSS, click on the minimum that you need, click only on the tests that you want, because that will simplify your output and it makes it less likely that you will cause a human error. So we definitely want descriptive, so we're going to do that. We're going to hit continue. And then we're ready to go. We're going to hit OK. And we have ourselves our SPSS output. So if you haven't finished running your test yet, pause, run the test, double check it against what we found here, and then meet me back here, and we are going to go through how do we actually analyze this output. All right, so back to the matter at hand. We have our SPSS output here. Let's zoom in a little bit on those top two tables here. And on that top table there, we have descriptives. And this was the option that we asked SPSS to calculate for us. And this is, again, where we're going to double check to make sure that the data we entered is correct. We entered it in correctly. This is going to give us the confidence to move forward boldly when we're interpreting the rest of this output. So very nicely, SPSS tells us that this is for the dependent variable subjective well-being. So if we had more than one dependent variable, it would tell us which one the table was for. So this is subjective well-being. And then because we labeled our conditions, instead of giving us the mean and standard deviation for category 1, it gives us the mean and standard deviation for prosocial boost. So again, this makes it easier on our human minds. This offloads our working memory into SPSS to take advantage of what SPSS does well. But importantly for us, we can check prosocial boost, 60 subjects. That's the right number of subjects. Mean subjective well-being of 0.23. That's the right mean. Standard deviation of 0.79. That's the right standard deviation. That's what we had in our Excel sheet. So we got that condition entered in correctly. What about prosocial blocked? 60 subjects. That is correct. Subjective well-being mean minus 0.16. That is the correct mean. Standard deviation 0.8. That's the correct standard deviation. What about our last condition, the personal condition? Personal condition. Number of subjects 61. That is correct. The mean minus 0.12. That is the correct mean. Standard deviation 0.87. That's the correct standard deviation. And in total, we have our 181 subjects. So again, this gives us the confidence that we've entered it in correctly. We've entered our data in correctly. We know we haven't made a human error, so we can go forward boldly with the interpretation of our data. Now, another thing that this allows you to do is it allows you to just kind of do a quick kind of synopsis of the story up to this point, because we didn't really take a look at plots just for time purposes, just to kind of keep this video within a manageable span of time. We didn't do the full analysis, but even if you haven't plotted your data, you can kind of take a look at the descriptives here and get an idea of what we might be finding later on. So what I mean by that is you can take a look at the prosocial boost category and say, hey, there's a mean of 0.23. That's a positive amount of social well-being. That's on the positive side of social well-being. So the prosocial boost had positive social subjective well-being scores. What about prosocial blocked? Well, it had a mean that was negative. So we're probably going to be seeing a difference between prosocial boost and prosocial blocked. There's probably going to be a significant difference there. What about personal? Well, personal is actually really close to the prosocial blocked. So we can see already that we can kind of start imagining and theorizing and hypothesizing, speculating about what it is that we might find. And that is often a great way of trying to get an understanding of what it is that we're actually looking at and changing it from numbers to something that's actually meaningful. So we're looking at this and we're saying, hey, the prosocial boost condition is very different from the prosocial blocked and the personal conditions, which seem to be very close to each other. So let's see if that's the actual story that occurs. And doing that kind of mental warm-up for the ANOVA helps you make a lot more sense of the ANOVA once we finally get to those numbers. And when are we going to get to those numbers? We're going to get there right now because we are going to take a look at this table here, very helpfully labeled ANOVA. So where do you go for your ANOVA statistics? You go to the ANOVA table. Once again, SPSS very nicely says, hey, this is the subjective well-being ANOVA table. And it gives us these 3 rows and multiple column table here that has all the information that you need for a ANOVA significance test. So we're going to take a look at what that information is, and then I'll explain exactly what it is or what it means. So it gives us what it calls between groups. And importantly, for our purposes, it gives us the degrees of freedom for the between groups and the mean square for the between groups. So there's this mysterious between groups variance, and it's got 2 degrees of freedom, and it has this thing called the mean square. And then there's this other entity here called the within groups. And the within groups has a certain number of degrees of freedom, and it also has a mean square score. And spoiler alert, that mean square scores, those 2 mean square scores produce our F statistic, and then the F statistic gives us our significance value. So we're going to get to the F statistic in just a moment, but we're going to rewind a little bit, and we're going to talk about between groups, and we're going to talk about within groups, just so that we can understand the fundamentals of what an ANOVA actually is. Because an ANOVA is analyzing variance, it's an analysis of variance. So these between groups and within groups, that is the variance that ANOVAs are analyzing. So what is it doing? Well, let's start off with the between groups variation. So we go back to our experimental design. We have 3 different conditions: prosocial boost, prosocial blocked, and personal. And the prosocial boost condition, it has a certain mean, right? It had that 0.23 subjective well-being mean. And the prosocial blocked condition also had a mean. I believe it was minus 0.16. Personal had a mean. It was minus 0.12. But importantly, there's variation between those group means. So the mean for prosocial boost did not equal the mean for prosocial blocked, did not equal the mean for the personal condition. So what we have is we have variation between the groups, and that, not surprisingly, is where our between groups variation comes from. So the between groups variation is a measure of how different are those 3 groups from each other. What is the variation between the 3 different groups? So it measures those differences in the group means. And this is the variation that is explained by the independent variable. So this is the variation that is explained by the condition that they were in, the prosocial boost, prosocial blocked, or personal condition. That is the difference between the 3 conditions. So the differences in the means for those samples can only be due to the differences, not only be due, but is a measure of how much the independent variable is changing your subjective well-being scores. So we have this between groups variation. We also have what is known as within groups variation. So within groups is basically exactly what it says on the tin. What is the variability within each group? What is the variability within each condition? Because if you recall, we had 60 subjects in the prosocial boost condition. And those 60 subjects gave 60 different answers. And those answers were not all the same. So some subjects had high social well-being scores, some subjects had low social well-being scores. Importantly, there was variability within this particular group of the prosocial boost sample, and that variability within this group contributes to the within groups variation. So you have within groups variation coming from the fact that the 60 subjects in the prosocial boost sample were different from each other. They were different from, they didn't respond in exactly the same way. And we have also the next condition. We have 60 subjects in the prosocial blocked condition, and those subjects didn't all respond the same way. They're all individual people. They all responded in different ways. And then finally, we have the 61 subjects in the personal condition, and they also did not respond in exactly the same way. So all of these all this variability within each sample gets pooled together in a way that we're not going to dive into, but basically gets pulled together, and it tells us how much variability in general can we expect. Because again, think about the 61 subjects in the personal condition where they gave the gift to themselves. Some of those people might just be happy-go-lucky people. Some of those people might just be having a bad day. Some of those people might have drank too much caffeine that morning and now they're super jazzed. Some of those people might be sleepy. Some of those people might be well rested. Some of those people might be in a hurry to get somewhere and are trying to get through this survey really, really quickly. There's going to be differences amongst all of those people. But the differences that we expect in those 61 subjects in the personal condition, those differences should be comparable to the differences to the subjects in the prosocial blocked condition and the differences in the subjects in the prosocial boost condition. And basically, that gives us a measure of, on average, how much variability can we expect. And then we're going to compare that to the variability that we found between the groups. So the within groups variation, you can think of it as a baseline amount of variability. And then the between groups variation is the extra variation that gets added on by the manipulation, by asking them the different questions. And then the F statistic uses both of those in its calculation. So back to the SPSS. So again, we have our ANOVA table, we have our subjective well-being, and we have our between groups, and the degrees of freedom is 2. The mean square, you can think of that as a measure of the between groups variability, the average variability in the between groups, the average variability between, the 3 conditions. And then we have our within groups, degrees of freedom 178, and it has a mean square score. And you can think of that mean square as, again, the average variability within all 3 of those groups. And then if you take the between groups mean square and you divide that by the within groups mean square, you end up with your F statistic. So if you want to double check that, you can pause the video right now, give that a shot. But if you take that 2.767 mean square for between groups and you divide it by 0.64 mean square for within groups, you get our F statistic. So the F statistic is basically telling you by what multiple of the within groups variation did we find in the between groups. So within groups is the variability that you would expect to find if there was no effect of the type of question. The between groups is the variability that we actually found, and between groups divided by within groups gives you that F statistic. So what does that F statistic actually mean? Why does it give us a significance value that is our p-value of 0.018? Well, for that, we are going to go back to our web browser here, and we're going to go over here to F distributions. And we're going to pretend that you didn't see that, and we're just going to start it off from the beginning. So we're going to have operation calculate an area under the F curve, because we're going to calculate the area in the tail of the F curve. An F distribution here has 2 degrees of freedom. It has your numerator degree of freedom and your denominator degree of freedom. Your numerator degree of freedom, that is your between groups, and SPSS told us that that was 2. The denominator degrees of freedom, that is your within groups. SPS told us that that is 178. And we're going to plot the distribution. And this is the F distribution right here. And just like the T distribution that we used, just like the distribution of sample means, this F distribution here, this sloping line right here, this is a histogram of millions upon millions upon millions of replications of this experiment if there was no effect of the type of giving that you did. So if the null hypothesis is true and the type of giving, prosocial boost, prosocial blocked, or personal, had no effect on your subjective well-being, and we ran that experiment millions of times, and then we plotted the F statistic coming out of each experiment, this is the distribution that we would get. So you can see that there are lots of F statistics out of these millions of experiments that are low in the 0.5 to 1 area. And then as your F statistic gets higher, those samples get rarer and rarer and rarer. So this is if the null hypothesis is true, what we would expect to get from this experiment. What F statistics would we expect to get from this experiment? What did we actually get? Well, the value that SPSS calculated for us was 4.105. And when we calculate that area, and we're going to show the labels on the plot, there's your F statistic of 4.105 right there. And the number of samples in the null hypothesis, if the null hypothesis was true, the proportion of samples that would give us an F statistic as extreme as the one that we found or more extreme, that is just 1.81% of the samples. So we had an F statistic here of 4.105. There is a 1.81% chance that our samples come from the null hypothesis, that our samples belong to the null hypothesis. And since there's only a 1.8% chance that it belongs to the null hypothesis, we say, hey, we're going to reject the idea. That's way too low. That's below our alpha level of 0.05. We are going to reject the idea that our sample came from the null hypothesis because there's only a 1.8% chance that it actually did. And we're going to reject the null hypothesis and we're going to accept the research hypothesis, the alternative hypothesis, and we're going to say that it does not belong to the null hypothesis, that at least one of these conditions is different. So this is what the F statistic actually means. It's basically saying, hey, out of all the samples that we could possibly get, if the null hypothesis was true, we ended up with this one. Very unlikely that it would ever happen. So we are going to say, hey, we didn't get super unlucky here. The null hypothesis is wrong. We're going to reject it, and we're going to accept the research hypothesis. All right, so that is what the F statistic is actually doing. Back to SPSS, and let's keep interpreting here. So we've rejected the null hypothesis because our p-value significance, it's called in the ANOVA table, is 0.018. And then the last thing that I want to show you here is the ANOVA effect sizes that we also clicked on. So this table here. So this is a great way to calculate out some effect sizes if you need effect sizes. So again, SPSS, very friendly. This is subjective well-being. And one of the more used effect sizes is the eta squared, also known as partial eta squared. And there's your point estimate right there. So if you need to calculate out effect sizes, this is where you would go to in your SPSS output to get those. We're not going to dwell too much on this. We're going to go back to that ANOVA table because importantly, we found our F statistic of 4.105 and our p-value of 0.018. So now we're going to see how you would report this in an actual paper. We're going back to Aknin and their study here, and we're going to take a look at their analysis. So they had their one measure of subjective well-being, and they write, using this measure, we conducted a one-way ANOVA. They mean a one-way independent means ANOVA, but we conducted a one-way ANOVA comparing the well-being of participants. The overall analysis revealed a significant effect. F, 2 degrees of freedom, 178 degrees of freedom equals 4.18, probability less than 0.02. So that 4.18, that is your F statistic. We were a little bit off because we were recreating the data, so we lost some precision when we were rounding. But in general, that is it's very, very close. That is your F statistic there, 4.18. That is your between groups degrees of freedom. Remember, that is your numerator. That is your within groups degrees of freedom. That is your denominator for the F statistic. You need to report both when you're reporting your ANOVA results. And also when you're reading the ANOVA results, make sure that you take a look at those degrees of freedom. So just, note what the degrees of freedom are, and they need to be reported because, again, the F distribution depends upon both of those degrees of freedom. So that's where you find them. Your between groups degrees of freedom is the first one. Within groups degrees of freedom is the second one there. And then importantly, for our final decision, we have our p-value. Again, we got really close in our analysis. Rounding errors kind of accumulated a little bit there. But we have our p-value of less than 0.02. That is less than 0.05. So what that means is that we reject the null hypothesis. All three of these conditions are not the same. all three conditions do not lead to the same subjective well-being, and we accept the research hypothesis, specifically that at least one of these means is different. So the ANOVA has now shown us, provided evidence that this is actually the case, that we accept the alternative hypothesis, at least one mean is different. But then there's that question, well, it says at least one mean is different, so which one is it? Because that is something that the ANOVA has not told us yet. And further, it has not told us which situation it is. Is there at least one mean that is different? Sorry, is there only one mean that is different? Is there two means that are different? Are there three means that are different? What is the pattern of how the means are different? Which one of these situations that we talked about before, or the multitude of different situations that are possible in this experimental design, which one of those is actually the case? And most importantly, how do we find out? Well, that is going to be covered in our next video when we complete our look at ANOVA. But this one here got you to the F statistic, got you to the p-value. So next time we meet, we're going to see how to go beyond that to finish the story so we can figure out exactly what it is that we are doing. But until then, that is all I wanted to cover for today. So I will see you all next time.